Good morning, students. Today we are going to discuss about the topic of wave packet, and we will derive a relationship regarding group velocity and phase velocity wave packet. Okay. So firstly we will discuss what is a wave packet. A wave packet is a wave packet or a wave group is actually it is a group of two or more waves that are superimposed upon each other, right? A wave packet or a wave group, that is a superimposition of two or more wave trains, right? That is called a wave packet. And a wave packet, let us consider two or more wave trains, wave trains which are superimposed upon each other, are represented by y1 is equal to a cos omega t minus kx, and y2 is equal to a cos omega plus d omega into t minus k plus dk into x, right? So these are the two wave trains having slightly different angular frequencies, omega and omega plus d omega, and propagation constant k and k plus dk, right? And now these two wave trains are superimposed. Apply principle of superimposition. So apply principle of superimposition on above two equations. You will get y, the resultant equation, is equal to y1 plus y2. So I just add these two, so it will become 2a cos. So instead of 2a we just write first equation plus second equation, a cos omega t minus kx plus a cos omega plus d omega into t minus k plus dk into x, right? So I just write here y is equal to this becomes 2a. Now I apply CD formula. So what is cos C plus cos D? Cos C plus cos D, that is 2 cos C plus D by 2 cos C minus D by 2, 2 cos C plus D by 2 cos C minus D by 2. So I just take this as C and this complete as D, right? So what I will do, I put this formula here in this equation, and you will get y, this is equal to 2. So 2 times 2a cos C plus D. C plus D means this thing plus this thing. So I just write here omega t plus omega t, 2 omega t minus kx minus 2 kx. So I just write here omega t plus, also along with that, plus d omega t. So I just write here omega t plus d omega t, omega plus d omega by 2 into t minus k plus here dk, c plus t minus I just take common, dk minus common, dk, k plus dk into x by 2, k plus dk by 2, right? I just take it a full form, right? Now this is c plus d by 2. Now I just write c minus d by 2. C minus d means this thing minus this thing. Now omega t minus omega t cancel, and minus kx, this one is plus kx also cancel. Rest of the term is d omega t, d omega by 2, yeah, just write d omega by 2 into t minus dk by 2, minus dk by 2 into x, right. Now since d omega and dk are very small, right, okay, it's cleared. Okay, since d omega and dk are very small, so we just neglect the terms d omega and dk. Y is equal to 2a cos omega by 2 into t minus d minus k by 2 into x, right. I just neglect the terms d omega dk. Here also along with that cos of d omega by 2 into t minus dk by 2 into x, right. No, okay, fine. Now y is equal to now this is the equation, I just write here, this is equation star. So now equation star is superimposition of two or more trains, wave trains, or we can say equation star is equation of wave having angular frequency omega by 2 and propagation constant k by 2, on which there is another wave which is superimposed on this wave, that is having angular frequency d omega by 2 and propagation constant dk by 2. Now what is group velocity? Here if we take, because this is a group of waves, so group velocity that is noted by d omega. Here I just write here, instead of first is instead of group velocity I just take phase velocity. So phase velocity is noted by Vp. So Vp that is equal to omega by 2 over k by 2, it becomes omega by k. This is the phase velocity, right. And group velocity Vg, that is d omega by 2 over dk by 2. I just cancel the denominator part and we will get d omega by dk. This is the phase velocity, oh sorry, group velocity. Vg is d omega by dk. So just remember this, the phase velocity is given by omega by k and group velocity is given by d omega by k. And also one more thing, if you want to find the phase velocity, and if we take velocity is nu into lambda, that is frequency into wavelength. So I just write here phase velocity that is equal to nu into lambda. If we multiply nu by 2 pi, that is 2, and divided by 2 pi, it becomes 2 pi nu over 2 pi into lambda. So what is this thing? 2 pi nu. This 2 pi nu is omega over, this is 2 pi by lambda. What is this? This 2 pi by lambda is k, propagation constant. Now so this is phase velocity omega by k, right. And Vg, that is group velocity, is given by this another part of this, that is d omega by dk. Okay, thank you very much.